So, given that I'm not going to be able to do the lab, and frankly I have to keep stopping, so I'm going to record a session rather than try and do one live. So yeah, I'm just going to post up various videos on this page instead. But if you do have questions, do send them through to me. I'll try and give you a hand on, or you can always post sort of updates. So to start with, what I want to do is make sure that actually you're sort of up to date with where you need to be. So that's the first thing. What I'd like to refer you to is the sessions that are on the OneDrive. On the OneNote document, which you should be accessing now for every session. And this is generally your go-to for all the bits of information and everything. So you should be using this regularly. Hopefully this isn't a surprise to you, otherwise if it is, you're already quite behind. So in the session 2, so this is what you did last week, or last session a fortnight ago when you were collecting your data. This is what you should have been looking at around that. So on that bit there is an example lab diary, and in the tab just above it, just here, there are, when it loads, there we go, there are some pages scanned in. Again, I told you about these, but just to remind you that this is a lab diary for a pendulum experiment. So it's in my terrible handwriting and there's crossings out, and like I said, it's a working document. The black is the lab diary. The red is like my annotations as a lecturer, as a tutor on it. So that's me sort of putting notes and things on and just trying to teach you. But there are little videos as you go through that explain each segment. So I'm hoping really by now you'll have studied, you certainly should have studied the beginning of those, or at least up to sort of part 2, which is about collecting the raw data, which is where you now should be at. So although this is for a different experiment, what I would be expecting you now to have on your resistivity experiment is the following stuff. So you should have an aim. So the aim of the experiment written in, a short, simple statement at the top. You should have a procedure. So this should tell me what raw data you're going to measure. It shouldn't mention anything about like what you do with the data. So calculate the resistance. No, none of that. It's just what raw data do you need to collect and how did you do it, and a diagram that helps with that. Notice how the diagram has got a caption, so it's figure 1, and then a bit of a caption that tells me what it is. Also in here, you've got to make sure that you include a few things that are like reducing errors. So you're identifying potential sources of error and action taken to reduce them. Now the reality of this for you, for your resistivity experiment, is that you might have written a procedure and then you've come to do an experiment you were unfamiliar with. And it is difficult to write a procedure without having done the experiment, but obviously you would write up a procedure a little bit more perhaps after the event as well. So having done it, you really need to have gone back and perhaps updated your procedure. Possibly your procedure originally was just the basics of, okay, so I'll collect information on voltage and on current, and I'll calculate the resistance. Well, you can go and cross that bit out now because you don't want that in there. I'll calculate it, cross out any references to calculating anything we don't care. But you do want things like, so different lengths, collect the voltage, collect the current, take repeat readings. You don't need to tell me you'll take the mean of those repeat readings. I know what you're going to do with it. That's obvious. But the procedure is about how will you take them. So take repeat readings. How many different lengths will you aim to do? You might not have done that. You might have done more. You might have done less. You might have not done repeat readings at all, and you might have just done 20 different lengths. And you're not going to have repeats, but you're going to have lots of points on your graph. It might be that that's what you did. And if there are changes from what you planned, don't tear the page out. Remember, lab diary, you tear a page out, you lose your job. Do not tear a page out. Just you don't even have to cross out the bits that are wrong. You could literally asterisk them, put something in the margin, this has been updated, you write then the extra bit of information underneath it. You might even have done that after your results table. Updated procedure. That doesn't matter. It's there. That's the point. That's the important point. You might go in and put in stuff about how you reduced certain sources of uncertainties, like you didn't realise that the wire wasn't going to be straight. You know, it wouldn't be perfectly straight and it wouldn't be under any amount of tension. Maybe you didn't put in the idea about measuring the length, measuring the diameter at different points along the length. All sorts of stuff. Maybe you put in your procedure, or didn't mention your procedure, what sort of voltage and current you were going to use. Well, having fiddled with the equipment and gone, oh, I could get maybe 1 or 1.5 or 1.2 volts or whatever, and I could keep it constant. But you can go and add that into your procedure as well. So you can retrospectively fill up your procedure. If it helps, notice in the example there's an extra little diagram. Diagrams are there to aid what you're trying to say. Alright, so rather than you having to really complicatedly explain what you mean by well, there's a bolt, but it's actually set at 1 centimetre, so the lengths I measure aren't what the ruler says. I've actually got to record a different length because the wire doesn't start at 0. I'm hoping that you potentially notice that. If not, you can correct all of your work. Maybe a little diagram to show, you know, part of the ruler with a little screw in it or something like that, and the wire, and then a position, and showing where the length goes not from the beginning of the ruler but from the little screw to the position that you're trying to measure. Maybe a diagram would be easy to explain things like that, for instance. Okay, you don't have to, but the point of diagrams is they make your life easier. If they don't make your life easier, don't put them in. You'll also notice that the procedure is not written in bullet points or step-by-steps. It's continuous prose. And if it appears in a couple of places because you've come back and written extra bits in, then it won't even be in order. Doesn't matter, because I'm not going to follow it like a recipe. I'm going to read the whole thing, figure out what I've got to do, and then do it. And if it's in 2 different places, I'll read all the bits, and then I'll do the experiment. So it doesn't matter. This is meant to look like it's lab notes, because that's what it is. So, okay, so don't worry. The reason I've left mine like this is because this is what I expect yours to look like. I know that some people have typed this up. That is a little bit unusual, but actually these days a lot of people probably would. It's very difficult to arrange these and put the diagrams and things in though. All I'm going to say is the same rules apply. If you've typed it up and if you've typed up your results tables and things, then you know all the same rules apply in terms of layout, in terms of captions, and in terms of all the stuff that's going to come next, as well as regarding calculations. You've got to do it. You can't just have an Excel spreadsheet where it's all calculated for you. That comes next, and it's great if you can do it. And if you've got it in Excel, why not have that check the values for you? But you've still got to put all of the calculations and everything in. Okay, so if you have typed this up, yeah, okay, not a problem. But it still is a lab diary. It still needs to follow all the same rules as the lab diary, and it's got to be effectively done by you. The only thing that is different about that is the graph has to be done by hand. It's probably the last time you'll ever do a graph by hand, but you need to be able to do them, because one of the things that you will do is when you're quickly sketching out data is just doodle a quick graph on a back of the envelope kind of style. And you need to know how to plot a graph. You need to understand the mechanics behind a graph, which is why you're doing this one by hand. But that's something we'll talk about in a minute or two. Okay, so remember to use this example. Although it's a completely different set of theory, the idea of it is still exactly the same. Just the processing, what you do with the numbers is different. But everything from sort of layout and the kind of things that you've got to do, this is a really good example for you to be able to follow. So make sure that you have had a really good look through this. And if you haven't looked through the rest of it, now is the time to look through the rest of the pages of the examples, because these will take you through all of the processing, all of the errors, the graph plotting, and the final comparisons, which is now what you're going to be going away to do. Okay, one other thing that doesn't show up on here, but you also need to include in yours, it isn't on here because it's a separate document, is the risk assessment. So that does need to be included as part of your portfolio. I would just add a little note in there to that effect. But if you're looking for that, again, if you can't find it, it's just back in week 1. This was the week 0 work. So this was all the health, safety and reflection stuff that you should have read on your induction week. And this talks you through all the physics angle, anyway, at least on the assessments. So if you scroll down a little bit, health and safety and professionalism stuff, there's some documents and things there that you can have a little look at. You just need to click on those so that they load up. Or if you have difficulty viewing them, you can just click on the link and it'll take you straight to an actual document, or one that you can download. And likewise, this is the risk assessment form. So make sure that you've also got this filled in. It's not a risky experiment, so this doesn't need to be, it doesn't need to read like a screenplay from a horror film. But just remember, as is in the guidance, and you should have already studied this, but just do remember that this is about protection of people from harm. It's not about protection of equipment. Alright? You're in trouble for a different reason if you break equipment, but that's separate, completely separate to this. So your risks have to be about protecting people from getting injured. And you have to distinguish between, each of the bits. So the hazards is effectively, just a quick summary of what the actual potential source of danger is. A bit more of a description, and the people who are at risk. And that might just be you, just the experimenter. You might do some experiments where other people will be at risk who use the lab, but in this case it's probably just going to be you. So the experimenter is all you kind of need to put in there. Risk controls is action you have taken to reduce the chance of it happening, or to control it if something does go wrong. So for instance, to pick something unrelated to what you've done, but like the chances of something being knocked over made of glass. So you would put some controls in place to make sure that it didn't get knocked over, or it reduced the chance of it getting knocked over, but also put some safety procedures in place. So, make sure that like where dustpan and brush is. Simple things like that. But you're reducing the risk at all the levels. So you're trying to stop it from happening, and you've got controls in place that if anything does go wrong, it reduces the chance of that causing harm. That's the kind of stuff that goes in here. They don't need to be lengthy. Okay, a couple of sentences in each one of these will probably do the job. And again, this has all been explained, but just a quick reminder. Extent of the harm 1 to 3 and likelihood. So how bad could it get? 1 to 3. Well, not very. It's a wire. It might get a bit warm. You could potentially... I've got a few places where I've lost fingerprints from bits of hot wire. It's not the end of the world. What's the likelihood of it happening? What the chances are of somebody getting hurt by this? Again, none of these are going to be particularly high. And then you multiply those two together to get the risk score. It is fine if your risk score is really low. In fact, I would question it if you got a risk score that was really high. You're either doing something dangerous or you're being a bit overdramatic. There is space on the bottom of these. Ideally, normally you'd get these signed by by yourselves and then by a member of staff. But obviously, with the situation we've got at the minute, everything's been a bit more online. So don't worry if it doesn't hold that second signature. Just make sure that you do sign it and fill it in yourself. Again, the idea would be you'd print this out and handwrite it. But no problem, if you want to sort of overwrite this as a PDF or something and hand that in, again, as long as it's legible, it's fine. But make sure you're using this form, not an alternative. It's the Physics Keele University Risk Assessment form. You're doing physics at Keele University, you need to use this form. So don't use an alternative. Okay. So one or two little things about your results table then. So, again, have a little look at the example. Notice basic things are number of decimal places are consistent in one column. So this is where time was measured and it was to one decimal place. It was recorded to. So they all need to be the same. Okay, they all need to match. Here is a different quantity. It's got a different number of decimal places, but within that column they all match. These will be calculated later. They do not need to match. All right, necessarily. They will be based on what was used to calculate them. So something like a mean would probably match the raw data it was taken from. But a calculated value like resistance, for instance, would depend on the two values that it came from. But you might not have those calculated yet. You can work out resistance quite easily, so I'm sort of hoping you've got that far at least. But I'm going to assume at this point that all you've got is raw data. So we'll be checking everything else that comes after that next. Notice then other things. You've got the units at the top, and you've got the quantity. Now you'll notice, put T and L, but in my procedure I've defined what T and L are, or at least on the diagram I've put what T and L are, so time period and length. So it's fine for you, for example, to write V and I. The only problem with this experiment, with yours, is you had two voltages. One of them didn't change, it was just there to monitor the experiment, and one of them did. That was kind of the variable you were measuring in the experiment when you changed the length. You have to distinguish between the two. if I just see one column of V and all the numbers are the same, and another column with V and they're all changing, I'm not going to have a clue what that means, and that's really quite bad if your raw data isn't easily understandable. So you need to make sure that you have come up with a way of making it clear. If I want to know what voltage is which, you can call them on your diagram, for example, V1 and V2, or V0 as the original sort of voltage that won't change, and then just V, but they have to be defined if you're going to use them. Also, if you're going to split up your tables in any way, so chances are you're going to run out of space in this one to do all the repeat readings and then calculate the means and then calculate the resistances, and then you're going to have to calculate errors as well. You're not going to fit this in a single table. So having trial numbers written in is a good idea. But again, you'll notice I've made a few mistakes in here. I started writing down extra decimal places that I didn't want, and I just put a line through them. I crossed them out. I shouldn't really have scribbled them. I should have just slightly more neatly crossed them, but I didn't tip-X them, I didn't rub them out. I wrote the trial numbers in the wrong places as well. I didn't leave myself enough space, so I just put a line through and put them again underneath. If you felt you'd made too much of a mess of this and just wanted to put a line through the whole thing and redraw it underneath, that would be fine. Don't tear the page out. Okay? Absolutely fine. Okay, and the very final thing that you should by now have is some observations. So these essentially don't really play a big part beyond this point in your lab diary, because you're not doing a qualitative analysis of your data. You're not doing a big description, big evaluation. But when you come to do your lab report, you will use these notes quite often to write your evaluation and say, oh, these are the problems I had. So this is stuff like, what did you notice? Stuff that may be inconsequential. You know, well, maybe the voltage didn't fluctuate, but it changed a little bit, or it changed halfway through, or the wire, you know, was the wire straight? Was it not very straight? Was you not able to keep it under any amount of tension, so it was a little bit kinked, and therefore the lengths might actually have been longer than you were measuring? You know, noting about the screw being not at zero. It can't be at zero, of course. So, you know, you've had to alter all your lengths to take that into account. So if you've not done that, again, that's something you need to, that's the level you need to be thinking about. This is a very straightforward experiment, but you've never done it on this level before, even if you've done it before at A level. You've had to really think about this one. And that's where you need to be at to be, you know, blowing this one out of the water a little bit. There's lots of bits to this one, so don't worry if you're not getting every single thing right. That's not what we're after. But the more bits you can think about and the habits you can build up in doing this one are what will carry you through. So just make sure you've got some observations there. Qualitative observations, put them under a little heading. Mine have been written weirdly in the middle of the page because I wrote them around my own annotations, I know, but yours just need to come in there with your results tables. And that's where you should be at this point. So I'm going to stop this one here, and I'm going to put another one up in a second that will tell you what you do next.